Good morning, students. I am Nidhi Bagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we discussed regarding the parallel combination of resistors and also the electric power definition of it and the formula of it. Today, we are going to solve a few problems from the textbook from it, and in the revision classes, we are going to solve more problems on this chapter. So today I'm going to select the concept or select the question from our NCERT textbook. So that question based on parallel combination is in page number 214. So it is example number 12.8. Okay. So example number 12.8, page number 214. All of you open that page. So here the question goes like this, guys. In the circuit diagram given in figure 12.10, okay, they have given the figure as 12.10, which is in a previous page, right? Yeah. So in that figure, what happens? Suppose the resistors R1, R2 and R3 have the values like 5, 10 and 30 ohm, which have been connected to a battery of 12 volt. Calculate the current through each resistor. Means I1, I2 and I3 we should calculate the total current in the circuit as well as total circuit resistance. Total circuit resistance means the resistance, total resistance when it is connected in a parallel combination, or we can call it as effective voltage. RP is also called as effective voltage. So what is the first step, guys? We have to write the given. So what is given? It is from page number 214, 12.8 problem. Okay. So the given is R values are given R1, R2 and R3. So let us write R1 5 ohm. Okay. Then R2 is 10 ohm. Then R3 is, I guess, 30 ohm. Okay, 30 ohm. These are the resistors, and the potential difference or the voltage of a battery used is, it is nothing but V is equal to 12 volt. V is equal to 12 volt. So to find, we have to find I1, I2 and I3 as well as IP. Next we have to find RP. Okay. So this is regarding the question and the things which we have to find. So first let us concentrate on I1, guys. So we know that when the resistors are connected in parallel, the total current will be equal to the sum of currents with passing through each resistor. The total current will be sum of current passing through each resistor. So there current will be changing, but the voltage, or we can say the potential difference, remains the same in parallel combination. So these we have to keep in mind. Okay. Now, so let us calculate I1. So I1 according to Ohm's law, we know that, Ohm's law, we can write this as V1 is equal to R1 I1. Why I did not write V1? Because potential difference remains same. So we know it is at 12 volt. R1 we know it has 5 ohm into I1. So when I solve for I1, 12 by 5, 5 twos are 10. Okay, 2 remains, again point 0, 2.4 I guess, right? So 12, 5, 2s are 10, 2.05, 2.4. So the answer will be 2.4 ampere. So this is I1, guys. Right? Same way, I2. I2 is equal to, we can write it as V by R2. What is V? V is nothing but 12. What is R2? It is nothing but 10. So it is 1.2 ampere. So I2 is 1.2, I1 is 2.4. Similarly, I3 will be equal to V by R3, where V is 12. What is R3? R3 is 30. So 2 15s are 2 6s are 3 2s are 3 5s are. So 2 by 5. So we can get around 0.4 ampere. Okay. So I1 as 2.4, I2 as 1.2, I3 as 0.4 ampere. So which we got. Next one. Total current in a circuit they asked. Total current in a circuit. In a circuit. So it is nothing but IP is equal to I1 plus I2 plus I3. Okay, this we know. Sum of the total current will be equal to sum of the current in the circuit in case of parallel combination. So what is I1 here, guys? The I1 is equal to, we got 2.4. I2 we got it as 1.2. Then I3 we got it as 0.4. So it is decimal. Better do rough work. Otherwise, due to silly mistake, we will lose the mark. Okay. So plus 4 plus 2 is 6. 6 plus 4 is 10. 2 plus 2 is 4. So it will be 4 ampere. So the total current, let us cross check. Yes, it will be 4 ampere. Now they asked regarding the total resistance in the circuit. That is nothing but the RP. Why RP? They mentioned the resistors are connected in a parallel. In the circuit diagram you can see the resistors are connected in a parallel. So 1 by Rp is equal to 1 by R1 plus 1 by R2. Right? So 1 by R1 is what here? So we have 3 resistors. So we will write, this is a different one, 1 by R3. 1 by R1. R1 is 5 plus 1 by R2. R2 is 1 by 10. 1 by R3. R3 is 1 by 30. Okay, 1 by 5, 1 by 10, 1 by 30. So when you take the LCM of it, or fine. So when you solve it, or when you take a LCM of it, 5, 10, 30, 5 ones are 2s are 3s are 2, 1, 3, 3, 1, 1, 1. So 5 2s are 10, 10 3s are 30. LCM will be 30, 3, 0, 5 6 are 6, 10 3s are plus 3, 30 ones are plus 1. So 6 plus 3 is 9, 9 plus 1 is 10. So 10 by 30. 10 ones are 10 threes are. So 1 by Rp will be equal to 1 by 3. We want Rp only. Therefore, Rp is equal to 3 ohm. Okay. So like this we have to calculate the Rp when it is given as a problem. Okay. So this is regarding the sum or the problem where we will be having parallel combination of series. Okay. Next. Next we will move on to the exercise question. The 13th question of exercise, where why I selected that question means there you are going to find everything, like you will come across the series combination, you will come across the parallel combination as well as the normal resistance also. Right? So that is why I selected 13th question from your exercise. Okay. So here let us open the exercise. 13th question. The question goes like this, guys. A hot plate of an electric oven connected to a 220 volt line, means the potential difference is 220 volt, has two resistance coils. It has two resistance coils. One is A and the other one is B. Each of 24 ohm resistance. Each of means the resistance of A is 24. The resistance of B is 24, which may be used separately. So we have to find the currents when the resistors are used separately and when the resistors are used in series, when the resistors are used in parallel. So overall we should find the current. Okay. Now in all three cases. So let us write given. So what is the question? It is from exercises. So it is the 13th question, guys. Given is nothing but the voltage. V is equal to 20 volt. Then RA, resistance of A. They named coil as A, right? That is why we will name it as RA. Is equal to 24 ohm. Similarly, resistance of B coil is equal to 24 ohm. To find I. So I in case of series separately, then in series, then in parallel. Okay. So separately we will find first. So when RA is connected, this is the first one. When RA is connected, okay. So V is equal to IA into RA. So we want IA. IA is equal to V by RA. V is 1220. RA is 24. So divide it. 2 12s are 210s are. Okay. 2 6s are 255s are. So overall you will get around 4.3. Overall when you divide, so you will get around, just see, it is 55. Let us do the calculation part here only so that you will understand. Okay. So here 6 by 55. Let us keep this side for rough work. 6 by 55. So 55, 6. 6 nines are 54, 1, 0. Okay, 0.0. 6 ones are 6, 4 you will get. Again 0, 6 6 are 36, 6 sevens are, okay, 6 6 are 36. So it is 4. 1 6 came. So as it is greater than 5, we can take it as 9.2. So here the current is 9.2 ampere. So when you take it for B also, it will be 9.2. Why? Because both the values are same, guys. Next, RA we can write or RB, because as both the values are same, you can write like this. Next one, I when connected in series. Current when connected in series. Okay. So let us do that. We know that when the resistors are connected in series, potential difference will be changing, okay, but the current remains constant, right? That is why we will take it as, first, as series we have to find, first we have to find the effective resistance, that is nothing but the total resistance in series. So RS can be written as here RA plus RB. RA plus RB, R1 plus R2. This is R1, this is R2. So RA is 24, RB is 24. So I will get what? 48 ohm. 48 ohm is a RS or a effective resistance or resistance in a series. Next, I is equal to V by RS. What is V? 220. What is RS? 48. So 12, we can say like, yeah, 4 ones are 4 12s are 4 55s are. So 55 by 12 you will get. Again we will divide the 55 by 12. So you will get around 12 fours are 48, right? So we will get 7.0. 12 fives are 60. So 10, again 0. 12 8s are 96. So you will get 4. 4.58. 4.58 you will get. Okay. So here as it is greater than 5, we can take it as 4.6 ampere. 4.6 ampere when connected in series. So current when connected in series, current resistors when connected in series, IS is 4.6 ampere. Similarly, they asked in parallel. So in parallel, we know that the current will be equal to I1 plus I2. That is IA plus IB. So we got to know IA. We got to know IA here. We got to know IB. So IA is equal to, it is around 9.2 ampere. Same way IB will be equal to 9.2 ampere. So we want total current in parallel. So in parallel combination, we know that IP, current in parallel combination, is equal to I1 plus I2. Here IA plus IB. What is IA? 9.2. What is IB? 9.2. So when you add 9.2 plus 9.2, 480, 9 plus 9. So it is 18.4 ampere. 18.4 ampere is current in parallel combination. Okay. So let us verify with the answers given behind. Fine. So 18.4 ampere. It is 18.3. They might taken this as 9.12. The decimal may change, but as 0.1 error is there, this answer is also correct. So like this we have to find the current when series, when parallel and separate combinations are given. Okay. This is regarding the problem based on parallel combination, series combination as well as separate resistance. Now we will discuss a problem, a single problem based on the electric power. So we will take it from the textbook itself. So in the textbook you have one example which appears quite tricky. So the example, the page number from NCERT, from Central State is 219. Page number 219. Okay, the problem is 12.3. The problem number is 12.3 example. So here the textbook, from the textbook I will read the question. So the question goes like this, guys. An electric refrigerator rated 400 watt. Means its power is 400 watt. So given, let us write, its power is 400 watt. Okay. Next, operates 8 hours per day. Means that 400 watt power operates 8 hours per day. Okay, this much watt refrigerator. Next, what is the cost of energy to operate it for 30 days at 3 per kilowatt hour? So at 3 per kilowatt hour, they asked to find cost. To find cost at 3 per kilowatt hour. Okay, so first we wrote the written. First what we have to write? We have to write the total energy. So this is the energy for one day. First we have to write the total energy we have to find, guys. So the total energy means what? 400 watt which occurs in 8 hours per day. So per day, 8 hours per day, into how many days we want? Into 30 days we want. So when you calculate it, 4 8s are 32, 32 3s are 3 2s are 6, 3 3s are 9. So we will get it around 9600 kilowatt hour. 9600 kilowatt hour is a total energy for 30 days. One day it is this much for one day. For 30 days into 30. So we will get 9600 kilowatt hour. Okay, 4 8s are 32, 3200 into 30. So 3 2s are 6, 3 3s are 9, 96,000. So we will get it around 96,000 watt hour. First we will get 96,000 watt hour, you can write. So as we want in kilowatt hour, so we can write this as 96 kilowatt hour. 96,000, 96 kilowatt, because 1 kilowatt hour is equal to 1000 watt hour. 1000 watt hour. So 96 kilowatt hour. Next we have to find 3 per kilowatt. So 1 kilowatt hour. For 1 kilowatt hour it is 3 rupees. So we want for 96 kilowatt hour is equal to what? So cross multiply. So that is 96 into 3 is equal to 3 6 are 18, 3 9s are 27 plus 28. So 288. It will be, let us cross verify, yes. It will be 288 rupees. 288 rupees for this much kilowatt hour. So like this we have to solve the problems on electric power. Here major thing is conversion of watt hour to kilowatt hour. Sometimes we forget, we directly multiply this with 3. It is wrong. We have to convert it into kilowatt hour because they will be giving the cost always in a kilowatt hour. So be focused while solving the problems, and solve the problems because they will give you the marks very easily. Instead of writing the long answers, if you solve a problem, it will it will save your time also, and you will get good marks also. Okay. So this is regarding the problems on electricity. We discussed regarding parallel, series, electric power, and regarding the current we already discussed. Okay, so here we completed the concept of electricity. In the next class, we are going to study the other concepts from chemistry and biology. Until that, take care. Have a nice day. Bye-bye.